In this video, we're going to look at one-dimensional motion and the ideas of displacement, velocity, and acceleration. So let's get started with displacement. Displacement, let me just get my pen here. Displacement, which we represent by x for motion along the x-axis, displacement is where you are. So where you are. And to help us visualize this, I'm just going to draw a little road up here. So this is in one D, or one-dimensional, and so we can view that as motion along a line, or you may be more familiar with motion along a road. So here's our road, and this can be your car. And so you're moving along this road, forward or backwards. That's one-dimensional motion. And so displacement just says, where are you? So are you at 0? Let me get back to my pen. Are you at 0? Are you maybe 1 meter away from 0? Are you 2 meters away? Are you 3 meters to the right? 4 meters? Where you are. So let's say your final position is 4, and you started off at 2. Then your change, that's just an arrow, then your change in position, and the delta, the triangle, means change. Change in position equals 4. You moved 4. Now, this is a good time to review what vectors are. So, a vector has a magnitude, that's a number, and a direction. Now, the direction for 1D, imagine this car is moving. It can either move forwards or backwards if it stays on this road. Okay, so if it stays on this line, if it stays in one-dimensional motion, we can have positive motion, or we can have negative motion. And so for 1D, direction is really just expressed via the sign. So by the plus or minus sign. In other words, for displacement, the little arrow, by the way, means that it's, so this little arrow up here means that it's a vector. Vector has that little arrow on top. If you were to say the displacement, you could say 4 to the right. 4 to the right means this spot right here. If you say 2 to the right, that would be this spot right here. If you say 2 to the left, or negative 2, that would be this spot somewhere back here. So the magnitude is important for how far away it is from 0, but the direction is also important, all right? Is it 3 in front, or is it 3 behind? So that's what vectors are. The next quantity we're going to look at is velocity. And so velocity is basically speed with a direction. So speed with direction. Remember, it's also a vector, so it's got a magnitude, which is the speed, and a direction. And so velocity is, it's how fast you're going with the direction. So it's maybe 4 meters per second. Meters per second. Now, how do you calculate 4 meters per second, other than just looking at your speedometer? Well, you would say, where was I? Where am I now? So let's say now you're at 4 meters. Where did I start off from? 0 meters, the origin maybe. And how long did it take me to get there? Well, if it took you 1 second, that's going to be 4 minus 0 over 1. And so mathematically, how do we express that? We just say x final minus x initial over time. Now, x final minus x initial is the change in x. So the formal formula for this would be the change in displacement over the change in time. And the change in time is just that 1 second it took you to get there. So this is how fast are we changing our displacement. 4 miles per hour, 3 miles per hour, 2 meters per second, 4 meters per second, and it has a direction. So you would say, I'm going 4 meters per second forward. That's very different than 4 meters per second backward, right? So let's say forward in our example. Okay, so that's velocity, and our final item to cover is the idea of acceleration. So acceleration is the change in velocity. We often don't want to, or as you're merging on the highway, you don't want to stay at 30 miles an hour. You want to go from 30 all the way up to 70. And so that mathematically is, we'd say, the change in velocity divided by the change in time. And so an example of this might be 10 meters per second squared. Now, how did I get this 10 meters per second squared, which, by the way, is the acceleration due to gravity? Well, you just take your, I'll write it out here, you take your velocity final, so it's the exact same as this displacement idea, velocity final minus velocity initial divided by time. So let's say our final velocity was 10. Let's say it was 100 meters per second, so pretty fast. And let's say our initial velocity was 50 meters per second. So we were cruising at 50 meters per second. We shoot up to 100 meters per second. And then let's say it took us 5 seconds to get there. And so the units for these guys on top actually is meters per second because it's velocity, so meters per second. So our velocity final, what we got to eventually, minus what we started at, divided by the time it took us to get there, is our acceleration. So again, formally, acceleration equals change in velocity divided by change in time. And so this, we got this definition, we've got this definition here for velocity, and then displacement is just where we are. Now again, all of these are vectors, so they have a magnitude, which is a number, and they also have a direction, but our direction in one-dimensional motion is very simple. It's just a plus or a minus sign. And